All right, class. In this example, we're asked to find VC, which is the voltage drop across both of these components, and find the power absorbed by the resistor. We have a 1 amp independent current source, and we have a resistor. That's what the symbol is, with a 20 ohm resistor. We're asked to figure out what the voltage drop is across this. Now, looking at this, I know that current's going to go this way. So if I draw the current across this resistor, I know that the current going across this resistor is going to be 1 amp as well, right? If we have 1 amp coming out of this, it's got to flow in a circle. We've got to have that 1 amp going through this component as well. We can't store charge in a resistor. So we're seeing 1 amp here. To find our voltage, we're actually looking at this. I've got voltage drop going this way. So we're actually, our passive sign convention is going to tell us, okay, if voltage is I times R, in this particular case, we're going to have negative I times R. Voltage is going to be a negative quantity because we're going to see voltage drop across this here. So our voltage drop, VC, is our current 1 amp times our resistance of 20 ohms. And it's negative, don't forget the negative part. So VC is actually going to be negative 20 volts. All right. And if we want to know the power we can also calculate directly. Now we could use our power formula. We use our power formula, it would be negative 1 times, or I times V, right? Remember that we have a drop across that. And because we have a negative voltage and a positive current, that would get us voltage times, amperage times voltage is going to give me 20 watts. And this is positive, it's being absorbed, right? So the power absorbed by the resistor is 20 watts. The other option that we could do is we could use one of our equations. We could use IR squared, that would also, or I squared times R, that would give us the same answer, or we could use our value, which is going to be R, V squared R, excuse me. Either one of those is going to get us to our answer. And in this case, if we're talking about the power absorbed, we would say the power being absorbed here is 20 watts absorbed.